All right, Daniel, tell us about this pet.
All right, this pet is a portable energy trailer, and the benefits of it are we have these solar panels on top and two awnings that fold out to maximize the solar output of this unit. It replaces a diesel generator, so it's green because you don't have to use diesel fuel. It's cheaper. Let's see, there's many different applications for it. Many ways to charge it other than just by solar. You can plug an EV truck into it to charge it. You can plug it into the grid if the grid's not down to charge it. And it has a backup generator in case it's like worst case scenario, and that's the only option you have. It runs off propane.
And why is there a pressure washer out? What are we prepping it for?
And we're about to send this to a construction site to replace the diesel generator for the first time, and it's pretty exciting.
And if you were a contractor, why would you want this?
Because I'm gonna save cost on fuel for one, which is a big one. For two, I could actually store materials in it, even though it's not really designed for that in this instance, but you could if you owned one. There's extra room inside. But you could run 2 houses off this, not at a continuous full load on those houses, but pretty much all your all your basic necessities.
Yeah, it's got the solar panels on the roof will make it great. You'll never have to run your generator if you're just running, charger batteries, running a couple 120-volt tools. And if you get into more serious applications like welding, etc., batteries kick in, and worst case scenario, your generator starts, right?
Absolutely.
So still has all the reliability you'd want of an on-site generator, with the added benefit that the generator does not turn on very much. The portable energy trailer is also our prototype for the National Energy Resilience device. And so what we've done is we looked at all the available solar and energy technology on the market, and we looked at what was the best for our application in the residential, small commercial space, and we duct taped it all together. And so this is our prototype. We've got inverters. We've got DC EV chargers that also let you charge your battery from an electric truck. And we have battery modules. We've got a smart electrical panel that controls your grid interaction as well as your smart sheddable loads. And hidden in this box is our cybersecurity device. We have these DC power supplies that make it so that we can run a generator, or as you'll see, we can even plug into the outlet, the 240-volt outlet of an electric truck for the brands that are not compatible with the DC charging. But what having a DC coupled generator does is it lets you run a generator whenever you want and not just when the grid is down. It also makes it so that all of your on-site power electronics, they run off of the waveform provided by that inverter. That inverter makes a beautiful sine wave. No matter how much load you're drawing, or if you have a big load that turns off, it's a computer, so it can catch up very fast. Whereas a generator is a mechanical machine, and so if you turn on your HVAC, your voltage drops and your frequency drops. And if you turn something off, you over voltage and you over frequency. That stuff's a little hard on your equipment. And so when we DC couple it, not only do we make the sine wave provided to a house a lot more cleaner in a backup situation, but we can run that generator when the grid is up. Now, why would you want to run the generator when the grid is up? Well, there's 2 very good reasons. First one, you might be choosing a power solution like the Nerd to feed a facility that needs to stretch a very small grid connection a lot further. And so if your grid connection is totally tapped and you don't have available battery reserve or solar present, you could turn that generator on, and then you could supplement and you could power more things on site. The second thing you could do is, if the grid is up and your generator is running and you are supplying power to the grid, you can keep doing that and the grid can count on that, because it's not at all dependent on what the weather is. As long as you have fuel and it's maintained, it will start up, it will provide power. And so the grid can start relying on these. They probably won't rely on portable energy trailers, but a national energy resilience device, rectangular prism, easy to drop in and have an electrician install. Then the grid can start relying on these. And as the grid starts relying on these, the biggest threat comes into play, which is this technology is all great, but it is beamed directly to a Chinese server. And so you have our national energy resilience device, and maybe that nation is China, but The key part of the nerd is identifying what supply chains can be ruggedized, can be US based, can be non-foreign entity of concern based, and with a movement stepwise to US manufacturing. That's a little bit of a stretch right now, but that is the goal, is to move in that direction and choose with each key component, where can we get that from that's not China? When can we get that in the US? Do we need to make it ourselves? Is there a partner, etc.? And to top it all off, we have in this box here our cybersecurity device. So this has onboard computational power. It has access to the internet, which in this trailer is a Starlink. It has access to backup cell power. And so as you have more and more reliance on these small energy devices as a utility grid, because you've recognized there's no way I'm going to upgrade my power grid and my big power plants fast enough. And so you might create a program that says, hey, any time in the summer when people come home and they crank up their HVACs, electricity is very, very expensive for a utility to provide because everybody's using it. And in places that have adopted solar, the sun's setting. And so you have this big spike in demand with supply diminishing. And so it's very expensive for utilities to get that power. And so what a lot of utilities are shifting to is time of use rates. And so they'll charge you more during certain times of the day and less during other. And it's just a very simple step forward to go, hey, what if not only did you charge differently, but you paid differently as well? Then you could have your batteries discharge power into the grid. And then as your batteries get low, you could be replenishing with your electric vehicle, with your generator. If energy was expensive enough, you could be shedding your on-site loads because the grid really needed it. And the grid was rewarding you in a way where it was worth it. And so that's kind of the engine that drives this, is it's people are going to get the nerd because they want resilience at their house. They want redundancy, generator, batteries, solar. They want that backup capability. And they also, would like somebody else to pay for it. And that somebody could be the grid. And so a homeowner would invest in this infrastructure for themselves, but the utility would pay to have access to it. And so they would say, hey, a bunch of small power plants all along our grid. We're seeing this right now with base power with a way worse technological option that does not have the cybersecurity built in from the beginning the way that we do. And so this is our nerd prototype. You can see it took a whole trailer to fit our form factor. Inverters, batteries, DC power supplies. This truck's actually not compatible with the DC to DC charging. And so we're just running a 240 outlet out of the bed into those DC power supplies. Works like a charm. The most common generator that people in the US have is the Generac Guardian. And so we put a 26 kilowatt Generac in here and it'll fully integrate with the system. Lets us work with people that already have a generator, not need to sell them something new. And on our trailer, we've chosen propane, but it doesn't really matter what fuel the generator uses. And you can see this was actually set up to be kind of a hub. And so it has a expanded transmitter device that won't be part of our prototype. But that's what happens in a prototype, is you install something and you realize that you should do it differently next time. So this is our prototype. It's in a trailer. We can hitch up to it, take it around, show it off. And it's also a functional power plant in of itself that does all of the things that we would want the National Energy Resilience device to do. And it just does it with 6 different brands of things in a way that's a little bit clunky. And so what we're looking to do is, instead of buying one brand's complete product of X, Y, and Z, begin acquiring the subcomponent assemblies and put them in our own enclosure with our own control scheme and our own cybersecurity, and put it in a box and set it next to people's houses and solve energy.
So this is an omni-win because the homeowner gets resilience, the grid gets relief during peak hours from the people that have this device. And also in the real big picture, we have bringing back jobs to America.
Yeah, we're gonna add American manufacturing. We're gonna power AI data centers. People are gonna switch to electric trucks with our current power grid. I don't think so. So we gotta do something about it. And I think there are lots of parts of the solution, but this is a big one. And it's one that, I'm not gonna decide to have a coal-fired power plant in my backyard. I'm not going to decide to have a wind turbine in my backyard, but I could decide to have solar panels, batteries, and a generator, especially if it was in an enclosure that made it so that I could just drop it off on a gravel area I'm an electrician, but if you're not, you could pay an electrician for a day to wire it all up and have it good to go, especially if I knew that it was going to be cyber secure and have built-in layers of redundancy so that if one system fails, the other ones, they keep chugging right along. And there are enough systems built in where even with just a few of the systems running, you have a very capable machine.
Thanks, Chris.